xy about the line y is equal to x is given by yx. Whenever we are reflecting any vector xy about the line y is equal to x, the x coordinate and y coordinate become interchange. Okay, so the instead of xy, so the t of xy, that will become yx, right? So if we take w is equal to t of x, then the equations w1, that is t of x1 x2, that is equal to w1 w2. So w1 is equal to y, that can be expressed as 0 into x plus 1 into y, and w2 is equal to x, that can be expressed as x plus 0 into y. So if we write down the standard matrix, then w1 w2, that is equal to, you can see w1, in w1 the coefficient of x and y are 0 and 1, so that is our first row, 0 and 1. In w2 the coefficients of x and y, are 1 and 0, so that is our second row of the matrix, right? Hence the standard matrix for the reflection operator about the line y is equal to x is 0 1 1 0. Similarly, reflection of x is equal to xyz belongs to R3 in the yz plane is w is equal to minus x y z, which is given by the equations w1 is equal to minus x, right, that is equal to minus x plus 0 into y plus 0 into z, w2 that is equal to y, that can be expressed as 0 into x plus 1 into y plus 0 into z, and w3 that is equal to z, that is equal to 0 into x plus 0 into y plus 1 into z. So okay, so reflection of x is equal to xyz in the yz plane is w is minus x y z. Okay, so w1 w2 w3, that is equal to the standard matrix. If you write down the standard matrix, just see w1, the coefficients of x y z in w1, that is minus 1 0 0, so that is our first row, minus 1 0 0. So w2 in the second equations, from the second equations, w2 the coefficients of xyz, that is 0 1 0 0 1 0, and w3 the coefficients of xyz, that is 0 0 1 xyz. Hence the required reflection operator is minus 1 0 0 0 1 0 and 0 0 1. Okay, next question, question 1b, question 1a complete. This question 1a is asked in 6 marks, and there are 3 questions. Out of 3 questions you have to write down the 2 questions, and each have 3 marks, right, in this question paper. Next question, question 1b, show that there is no line containing the points 1 1 3 5 minus 1 6 and 7 2. Okay, show that there is no line containing the points 1 1 3 5 minus 1 6 and 7 2. Suppose a line y is equal to a plus bx passes through the given points, then we have, suppose we have such line that passes through all the points, all the 4 points. So definitely the equations of line can be expressed as y is equal to a plus bx, can be written as y is equal to a plus bx. So passes through the given points, then we have, instead of x you have to write, suppose first point is 1 1, so instead of x you have to write 1, and instead of y you have to write 1, right? So a plus b, that is equal to 1, right? Next point is 3 5, so put, instead of x you have to put 3, and instead of y you have to put 5, so you will get a plus 3b, that is equal to 5, right? Instead of then minus 1 6, from minus 1 6 you will get the equation a minus b, that is equal to 6, and then 7 2, from 7 2 you will get a plus 7b, that is equal to 2. Now try to solve this 4 equations. A plus b is equal to 1, a plus 3b is equal to 5, a minus b is equal to 6, and a plus 7b is equal to 2. So the matrix equation for this system of equations, this 4 are linear system of equations we have now linear system of equation with 2 variable and 4 equations, right? So definitely you can solve using the matrix method of matrix. You have to convert this augmented matrix into a row echelon form with the same method we already solved in the previous example. So the matrix is 1 1, the first row is 1 1, the second row is 1 3, the third row is 1 minus 1, the fourth row is 1 7. Just see the coefficients of a and b in each equations. In the first equations the coefficients of a b is 1 1, in the second equations the coefficients of a b is 1 3, in the third equations the coefficients of a and b, that is 1 minus 1, and from the fourth equation you will get 1 7 into ab, that is equal to 1562, right? 1562. Now here is the augmented matrix. Hence the augmented matrix is given by 1 1 1, first row is 1 1 1, 1 3 5, then 1 3 5, 1 minus 1 6, 1 7 2. Now we have to convert this matrix into row echelon form, right? So that's why we convert this matrix into a row echelon form. We multiply first row with minus 1 and add into the second row, right? We multiply first row with minus 1 and add into the second row. So that's why the first row is as it is, 1 1 1. The second row become 1 minus 1, that is 0, 3 minus 1, that is 2, 5 minus 1, that is 4. We multiply first row with minus 1 and add into the third row. So 1 minus 1, that is 0, minus 1 minus 1, that is 2. You can see from the screen, minus 1 minus 1, that is 2, 6 minus 1, that is 5, right? We multiply first row. Next process is we multiply first row with minus 1 and add into the third row. So that's why the fourth row become 0, 7 minus 1, that is 6, 2 minus 1, that is 1. Okay, so the new matrix is 1 1 1 0 2 4 0 minus 2 5 0 6 1. Okay, now you can see from this matrix, the last matrix on the screen, the second, third and fourth row. Now next process, we multiply second row with 1 and add into the third row, and we multiply second row with minus 3 and add into the fourth row. We multiply second row with minus 3 and add into the fourth row. So that's why the first and second row are as it is, 1 1 1, second row is 0 2 4, third row become, you can see, we multiply second row with minus 1 and add into the third row. So the third row become minus 2 plus 2, that is 0, and 5 plus 4, that is 9. Okay, and we multiply second row with minus 3 and add into the fourth row. So the fourth row become 6 minus 2 into 3, that is 0, and 1 minus 4 into 3, that is 1 minus 12, that is minus 11. Okay, now next process, we multiply third row with 11 by 9 and add into the fourth row. So the fourth row becomes 0, right? So the fourth row become 0, and rank of A is equal to 2 and rank of augmented matrix A by B, that is equal to 3. So that's why the system of equations is not consistent. The system of equations is not consistent because rank of A, that is equal to 2, and in fact you can see from the third row, you will get 0 into x plus 0 into y, that is equal to 9. That is not possible. Okay, this matrix is already now in row echelon form, and from this matrix we will get one equation, that is from the third row you will get 0 into 0 plus 0 into x plus 0 into y, that is equal to 9. That means what? 0 is equal to 9. That is not possible. So that's why the system of equation is not consistent. So the line, you cannot find such line y is equal to a plus bx which passes through all the 4 points. So that's why the line y is equal to a plus bx does not pass through the given points. Okay, so here is the solution of this question. Next question, question 1c, first part. Find all vectors in R3 in Euclidean norm 1 that are orthogonal to the vectors u1 1 1 1 and u2 1 1 0. This question asking 2 marks. So basically you have to find all the vectors such that using the Euclidean norm such that all the vector have Euclidean norm 1, right? That means if we take x is equal to abc be the required vector, then definitely a square plus b square plus c square equal to 1. In fact, norm x is equal to under root a square plus b square plus c square, that is equal to 1. That means if we take square on both the side, you will get a square plus b square plus c square is equal to 1, right? And the next condition is we have to find all vectors such that Euclidean norm 1 and that is orthogonal to the vectors u1 and u2, where u1 is 1 1 1 and u2 is 1 1 0. So if you take, let x is equal to abc be the required vector, definitely norm x is equal to 1. So from norm x is equal to 1, you will get one equation, that is a square plus b square plus c square is equal to 1. Now x is orthogonal to u1. Now x is orthogonal to u1. Hence x into u1 is equal to 0. Hence x is equal to x into u1 is equal to 0, right? Dot product, into means dot product, x dot u1 is equal to 0. Now x is abc, so abc dot 1 1 1 that is equal to 0. So just dot product, use dot product, you will get a plus b plus c is equal to 0. That is our second equation, right? Now x is also orthogonal to u2. That means what? Inner product of x with u2 is equal to 0, but as a inner product we use Euclidean inner product, so that's why x dot u2 is equal to 0. So abc dot 1 1 0 that is equal to 0. Okay, so a plus b is equal to 0. So that's why a plus b is equal to 0. Now use first, second and third equation to solve, to find a, b and c. To find a, b and c, we use first, second and third equation. Put a plus b is equal to 0 in second equation, right? A plus b is equal to 0 in second equation. You will get c is equal to 0, right? Because a plus b is already 0 and second equation is a plus b plus c is equal to 0. So whenever you put a plus b is equal to 0 in second equation, you will get c is equal to 0, right? Now from the third equation you will get a is equal to minus b. Clear? From the third equation you will get a is equal to minus b. Put that value in the first equation. Put that value in the first equation, right? So now c is already 0 we have, and a is equal to minus b. So a square, from the first equation you will get this equation, a square plus minus of a square, that because b is minus a, you can replace b as minus a, right? So minus a whole square, that is also a square, right? Minus a whole square, that is also a square. So a square plus a square, that is equal to 1. That means what? 2a square is equal to 1. 2a square is equal to 1, correct? So that means what? A is equal to plus or minus 1 by root 2. A is equal to plus or minus 1 by root 2. See, from 2 and 3 we get c is equal to 0, because now and a is equal to minus b. Now from 1 we have 2a square is equal to 1. So hence a is equal to plus or minus 1 by root 2. Now if you take a is 1 by root 2, now what is b? B is minus a, so b is minus 1 by root 2. And if you take a is equal to minus 1 by root 2, what is b? B is 1 by root 2. Okay, so whenever a is 1 by root 2, b is minus 1 by root 2, and whenever a is minus 1 by root 2, b is 1 by root 2. Okay, so the required vectors are 1 by root 2, minus 1 by root 2, 0. Now c is fixed 0, right? And the second vector is minus 1 by root 2, 1 by root 2, 0. If you want to check, you can see norm of this both of vector have 1. Norm of this both of vector is are 1. Okay, and definitely the inner product with u1 and u2 that is equal to 0 of in both of vectors, right? So here is the solution. We find just only two vectors such that norm of that vector is 1 and inner product of u1 and u2 are 0 of these two vectors. So here is a solution of this question paper. Here is a solution of this questions. Next question, question 1c, second part. Find the rank of the matrix. Find the rank of the matrix A in terms of determinant. In terms of determinant. So generally we use to find rank of a matrix using row echelon form. We know that any matrix, if you want to find rank of any matrix, just convert that matrix into a row echelon form and just see that how many non-zero row in that row echelon form. That is exactly number of non-zero row in row echelon form. You have to see the number of non-zero row in that row echelon form. So that is exactly our rank of the matrix. Okay, but here we have to use rank of a matrix. To find rank of a matrix, we have to use determinant. Okay, we can, so that's why we cannot use that method. Now how can we use determinant to find rank of a matrix? Here we have square matrix, right? So it's quite easy to use, because of in square matrix, first of all you have to determinant of that matrix. That here we do that determinant of that square matrix, that is equal to 0. We will get how that is equal to 0, that is the next part, but determinant of that matrix is equal to 0. So in that case rank of A is not equal to 3, because this is 3 cross 3 matrix, right? Rank of A is not equal to 3. Now we have to use, definitely the rank of this matrix is either 1, either 2 or either 3, right? Or either 0, but 0 is not case, because this is not a 0 matrix. In 0 matrix the rank of that matrix is, you can say, 0, but this is non-zero matrix, so definitely rank of this matrix is either 1, either 2 or either 3. Now definitely the rank of this matrix is not 3, because of determinant of this square matrix we get 0, right? You can see how we find determinant, that is 2 minus 1 3, 4 minus 2 6, 6 minus 6 3 8.